Hello everyone. In the previous class, we was discussing about the equivalence class, and in this class, I am going to discuss about the properties of equivalence class. You see, first one, the properties of equivalence class. What are the properties? In the previous class, I already discussed about the basic properties of equivalence classes, and here we should write in as a note in your copy what are the actual properties of equivalence class. So first of all, you take let R be an equivalence relation. Let R be an equivalence relation on the set A, and small letters you write AB belongs to A. That is, A and B are any two arbitrary elements in the set A. Then what are the properties? The number one property we already discussed in the previous class, that A is always belongs to the class of A. You know that one. Now the second property is, if B belongs to equivalence class of A, then you will see that equivalence class of B must be equal to equivalence class of A. This is another property. Then I am writing here number 3. Either equivalence class of A is equal to equivalence class of B, or equivalence class of A intersection equivalence class of B is equal to 5. Mean they are pairwise disjoint. Either they are equal, completely equal, or completely different. That is one of the important property of equivalence class. And you see that if number 4, if equivalence class of A number 4 is if equivalence class of A equal to equivalence class of B, if these two equivalence classes are equal, then the order pair AB, this is belongs to the relation R. That is, the elements of the equivalence classes of class of A and the elements of the equivalence class of B. If these two are equal, then this A and B are related to each other by the relation R, that in the equivalence relation R. So these are the basic properties of equivalence classes. In the previous class, I already discussed in the example manner what are the properties of equivalence class. Already discussed in the previous class, and I have written here to note as a note what are the properties. If any element will present in its equivalence class, this is the first property. If any other element is belonging to the equivalence class of A, then class of this must be equal to class of this. As like class of 0, in the previous class you see your note that in the class of 0 there is the element 5 in the previous example, and class of 5 will also be equal to class of 0, as like that this one. And if equivalence class of A and equivalence class of B, these are two equivalence classes, then either they are completely equal or they are completely different. In fact, that means they are pairwise disjoint. And this one, if equivalence class of A is equal to equivalence class of B, then we see that the element A and the element B, these two elements are related to each other by the equivalence relation R. So this is these are the properties of equivalence class. Okay, so then we write partition of a set. You write partition on a set. What is partition on a set? That to be written here. So partition means that you write let A be a non-empty set and capital letter F be the family of the subsets. the subsets of A such that condition to be saba in a subset of family we have such that the members of F are pairwise disjoint and the union of the members of F is the set A. Then F is called a partition of A. So this is the definition. Try to keep A is not a set and F is the family of subsets of A. Family of subset means F of khali A subset means কিন্তু কেনেকৈ subset সেইটো হৈছে main condition, that is the main condition. The subsets of A such that the members of F, meaning those subsets you are taking, those members are pairwise disjoint, meaning the intersection of any two subsets is equal to 5, and the union of the members of F or the subsets থাকিব এগুলো union কৰিলে it is the set A itself. আৰু এই যে দুটা conditions তুমি লিখিছা, these two conditions actually are the conditions of equivalence class. Equivalence class tells us that the equivalence classes are pairwise disjoint. That means this condition is satisfied, pairwise disjoint. Just we discussed. And you see the union of the members of F. I discussed in the earlier classes that the union of all equivalence classes, this is equal to the given set. So this union of the members of F, meaning the subset union of the subsets is equal to the set A, then F is called the partition of the set. Like this, we have a try to type a simple expression. So this is the total set A. If you write like this subdivision, say this is F1, this is F2, this is F3, and F4, F5. These are actually what? These are actually subset of A. And you see, intersection of any two subset is fine because no overlapping. Overlapping intersection exists, but no overlapping is there. Therefore, they are pairwise disjoint. Apo ei duto eta union kore dile A set to ulai koribo, and hence these are the partitions of the set A. So, এই একেটাই property তোমার equivalence class এর উপর তো maintain হয়। So, whenever we ask to find the partition of a set, যদি মু partition উলিয়া কোনো set then actually we have to find the equivalence classes of the set with respect to some equivalence relation. তো যদি মু কোনো এটা সেটৰ partition কৰিব দিয়ে তেতিয়াহলে মই কি কৰিম, ফাৰ্স্ট সেই সেটটোৰ এলিমেন্টস বিলাকৰ equivalence class to determine কৰিম। আৰু যদি equivalence class কে determine হৈ যাব, সেই equivalence class বিলাক যেতিয়ালৈকে repeated নহয়, until the equivalence classes repeated, তেতিয়ালৈকে তুমি লিখি থাকা। So যেতিয়া লিখি পেলাই তুমি হেনেকে গম পাবা যে এতিয়া রিপিটিশন হ'ব, stop the process there, তাতে লগে লগে stop কৰি দিবা। আৰু তেতিয়া তুমি যেটা equivalence classes পালা, these are the equivalence classes and that's are the partition of the set given. Okay, so this is the partition of a set. So ইয়াতে বিশেষ একো টাফ কথা নাই একো। তো যদি তোমাক equivalence class equivalence relation এটা দিয়া আছে, set এটা দিয়া আছে, আৰু কৈছে what are the partitions, কিন্তু তুমি কি কৰিবা, simply find the equivalence classes. Equivalence class কেটা উলিয়াই লোৱাৰ লগে লগে তুমি ক'ব পাৰিবা what are the partition, মানে equivalence classes are the partition of the set. Okay, so এইটো টপিক আমাৰ ইয়াতে শেষ হ'ল। এতিয়া আমি এইটো চেপ্টাৰৰ যে কোৱেশ্চনছ আছে, we will discuss the questions of the chapter relation. So first I am taking this question number 1, state whether the following relations A is equal to 1 2 3 on the set A is equal to this one are reflexive, symmetric and transitive. এই রিলেশনস বিলাক মোক দি থোৱা আছে আৰু কোৱেশ্চন খুলিছে যে which of these relations are reflexive, কোনটো রিফ্লেক্সিভ হয়, সিমেট্রিক হয় আৰু ট্রানজিটিভ হয়, এইটো ক'ব দিছে আমাক। সো এইবিলাক তোমাৰ 1 মাৰ্কৰ কোৱেশ্চন থাকিব, গতিকে এইবিলাক মই লিখি দিয়াৰ বিশেষ দৰকাৰ নাই, জাষ্ট ডিসকাশন কৰি গৈছো মই। সো নাম্বাৰ 1 ইউ সি What was the property of reflexivity? Reflexive কেতিয়া হয়? Reflexive mean in the set, যেটো set মোৰ আছে, in the set for all elements you must have the image and pre-image are equal. সবকটা এলিমেন্টৰে image আৰু pre-image equal থকাকে যদি ৰিলেশন থাকি যায় তেতিয়াহলে তুমি ক'ব পাৰিবা this relation is a reflexive relation. So এইটো ৰিলেশন তুমি চাবা, this one mean for the element 1 1 for 2 it is 2 2 and for 3 it is 3 3. So for all elements we have 1 1 2 2 3 3. Therefore the relation R, number one relation R is a reflexive relation. Then symmetric relation কেতিয়া হয়? Symmetric whenever A B belongs to the relation R, then the reverse order pair, that means BA, if that relation, that order pair is again in R, then we say that the relation is a symmetric relation. And here you see the relation 1 2 containing in the relation R, and the reverse ordered pair is 2 1, that is also is in R. Therefore R is also symmetric relation. And thirdly, transitive relation. Transitive means if AB and BC, both these two ordered pairs is in R, then you just verify whether AC is in R or not. If AC is also in R, then you say the relation is transitive. And if AB and BC belongs to R but not AC belongs to R, then you say the relation is not transitive. But in case if AB and BC, these two elements are not in R, then you directly tell that the relation is a automatic transitive relation. So তুমি হেতু কথা মনত ৰাখিবা, যদি AB আৰু BC এই দুটাই যদি আলোক না থাকে তেতিয়াহলে এটো অটোমেটিক ট্রানজিটিভ বুলি ল'ব লাগিব, মই আগৰ ক্লাছত যি কৈ আহিছিলো। But in case AB and BC is in R, যদি সেই দুটা থাকি যায়, then you are to find whether AC is also in R or not. তেতিয়াহলে তুমি চাব লাগিব সিটো আৰু আছে নে নাই, যদি আছে transitive, যদি নাই not transitive. Okay, so this relation is reflexive পালো আমি, symmetric পালো as well. তুমি চাবা 1 2 and 2 1, so 2 to drop কৰি দিলে হৈ যাব 1 1, and that is in R. Similarly 2 1 এটো ফ্ৰন্টত আনি চাবা 2 1 then 1 2, 1 to drop হৈ যাব 2 2, and that is also in R. So this relation is reflexive, is symmetric as well as transitive. So তুমি ডাইরেক্টলি লিখে দেব the relation R is reflexive, the reflexive होइसे symmetric and transitive. तीनों मिलते हैं transitive. So that is the answer. Similarly, take the second question. Second is about this time 1 1 2 2, not 3 3. 3 3 থাকিব লাগিছে to get reflexive 1 1 2 2 3 3. তিনটা থাকিব লাগিছে, but 3 3 is not belongs to R. Therefore, you can say that the relation is not reflexive. Reflexive no more. Symmetric by the next one, it is 1 2 and 2 1 are belongs to R. Therefore, it is a symmetric relation. But reflexive no more. Symmetric whole transitive 1 2 2 1, then dropping 2, you will get 1 1 is in R, and 2 1 to front one there 2 1, then 1 2, 1 drop there. This is 2 2 is also in R. Therefore, it is a symmetric relation and it is a transitive relation, but it is not reflexive relation. So here the common to be like since 3 3 is not in R, so R is not reflexive. কারণ তো লিখে দেব পারে যদি নহয় যেহেতু again এটো ডাইরেক্ট লিখবা again R is clearly symmetric, clearly symmetric and transitive. Symmetric and transitive. So that is the answer for the question number 2. Similarly 1 1 2 2 3 3, this is reflexive. 1 2 2 1 and 2 3 3 2 would be reflex symmetric. Transitive one is 1 2 2 1, then 1 1 is here. So 2 3 3 2 2 2 is here. 2 1 1 2, then 2 2 is here. Then 3 2 2 3 is 3 3 is also here. Kintu non koriba, if you take this and this 1 2 and 2 3, 1 2 2 3. So if you drop 2, then it will 1 3 is not in R. গতিকে এই রিলেশনটো রিফ্লেক্সিভ হৈছে, symmetric but not transitive, because these two elements are in R, but 1 3 is not in R, therefore it is not a transitive relation. Okay, R is reflexive and symmetric. Reflexive and symmetric, but not transitive. Because why it is not transitive? Because 1 2 2 3 belongs to R, but 1 3 this is not belongs to R. But it is not transitive for condition. So similarly, that we find to 1 1 2 2 3 3 reflexive ways 1 2, but 2 1 is not present, therefore not symmetric. But 1 2 2 3 1 3 heterodyne, it is not transitive. It is only reflexive, neither transitive, neither symmetric, not symmetric. Okay, so this completes the solution of the question. If you have the next question to the whole. So take this question. Show that if the set A is equal to 1 to 12, the relation R is equal to xy such that xy is in A, and the difference of x and y, that is the component difference, is a multiple of 4, is an equivalence relation. So প্রথমে বল এই two relation equivalence prove করি। After that, find the set of those elements of A which are related to 1 by the relation R. So কোইছে যে এই R relation এর দ্বারা related হওয়া one element or level কোন জড়িত হবো এই সেটর, you have to find that set. So ultimately, actually by the second question it was actually you have to find the class of A. Class of A means class of 1 देते, तो class of 1 तुम्हारा बोलिए अपने से। Class of definition तो कि if A is the element of the set given set, then class of A is equal to it is the set of all those elements in the set given set such that those elements are related to this small letter A. So यहाँ तो तुम्हारा condition है find the set of those elements of A which are related to 1 by the relation R. গতিকে R relation এর দ্বারা 1 এর লগত এই সেটৰ কোন elements connect হবো সেই কারণে তুমি উলিয়াই নিব। So that means you have to find the class of 1 actually. And then another question asking here that also find the number of partition in the set A with respect to the relation R. Partition to কিমানটা হবো সেইটো উলিয়াই কৈছে। Partition means again in this case also you have to find the equivalence classes of the elements. এই elements গুলোর equivalence class উলিয়ালে তুমি কব পারিবা what is the number of partition of the set above the relation R. So let me solve this problem. এটো তোমার বুকতে আছে question 2. First of all, you have to show that this relation is a reflexive relation. So for that you have to take let reflexive এর কারণে একটা এলিমেন্ট লগে মই স্মল লেটার x এর ইউজ so let x is belongs to the set A, then x to a লগে নিব। So reflexive check করার কারণে one element, symmetric check করার কারণে two elements, and transitive check করার কারণে three elements লগে লাগে। এটো তোমার মই আগের ক্লাসে পড়তে হইছিল। So let x belongs to A such that then relation to this one, then modulus of x minus x, obviously this is 0, and 0 is also a multiple of 4. A relation to minus this. So which is a multiple মানে গুণিতক, multiple of 4. তো তোমাকে একটু ডিভিশন অফ 4 বললে কব পারে যে 4 এর বিভাজ্য এটাও কব পারে কথাটা এটাই। So which is a multiple of 4, therefore যেটা এই কথাটা মানে চলিব এটা লেখা আছে multiple of 4 হওয়ার লগে লগে অর্ডার পেয়ার corresponding order pair আর আহি যায়। So therefore you have to write the order pair xx, this is in R, and this is for all x belongs to the set A. A set of সবকে এলিমেন্টের কারণে এই কথাটা মানি। Therefore R is a reflexive relation. So the first one is proved. Then come to second one, symmetry. So this time you have to take two elements. I already told you that to check whether relation is symmetric or not, you have to take two elements from the set. So let the two elements say x and y, these are belongs to the set A such that you have to take two elements from the set in such a way that such that this ordered pair xy is in R. And finally, you have to check whether the reverse ordered pair is also in R or not. মানে xy যদি R আছে তুমি মিলাই যাব লাগিব যে whether yx is also belongs to R or not. So তার কারণে xy, as we have taken xy is in R, যেতিয়া মই xy R কৈছো, consequently তুমি লগে লগে লিখিব পাৰিবা modulus of x minus y is a multiple of 4. লগে লগে তুমি ক'ব পাৰিলা যে x minus y এটা 4 ৰ গুণিতক, and that is implies and implied by obvious into. So y minus x is also a multiple of 4. So y minus x এটা 4 ৰ multiple হবে, and that is implies and implied by যেতিয়া y minus x multiple of 4 হৈ গৈছে লগে লগে corresponding ordered pair is yx is in R. yx to R থাকি যাব, তার মানে xy is in R, we see that yx is also is in R. So therefore R is symmetric. Therefore R is symmetric. So second condition was satisfied. Even third part, this time you have to take 3 elements from the set. So you take let x, y, z belongs to. So this time you take let x, y, z, all this belongs to the set A, such that such that the ordered pair xy belongs to R and the ordered pair yz is also belongs to R. এই দুটো বস্তু আমি আর করব xy and yz. Now our target is to check whether xz is in R or not. সেইটো আছে নাই চাব. So consequence বিলাক লিখি দিবা, xy belongs to R mean mod of x minus y is multiple of 4, and from here mod of y minus z is multiple of 4. গতিকে দুটাই মই লিখি ললো। So multiple of 4 mean mod of x minus y, this is actually 4k1 type, and y minus z, this is also 4k2 type, and where k1 k2 these are integer number, positive integer, you may also write positive integer. So after that this is implies x minus y is equal to plus minus 4k1, and from here y minus z is equal to plus minus 4k2, just removing the modulus sign and now adding into the plus for you x minus y plus y minus z is equal to plus minus 4 is common, then k1 plus k2 will be there and a kind of. So y is cancelled here, we see it is x minus z is equal to plus minus 4, k1 plus k2 can be taken as k, so you may write here k is equal to k1 plus k2, and that is also belongs to a set of integers z. Okay, so that is implies here this one can do this one, that is implies it actually mod of x minus z is equal to simply 4k লিখব পারিব, mod plus minus 2 satisfied, and this will imply mod of x minus z for beta, so you may write like this, mod of x minus z is a multiple of 4 তুমি এর লিখিব পারিবা, and so that is implies এই কথাটো কোৱাৰ লগে লগে এই কথাটো মানাৰ লগে লগে the corresponding ordered pair is xz belongs to the set R with the relation R. So lage lage xz to R আহিব. So our supposition was xy and yz is in R, and finally we have seen that xz is also is in R. So therefore you can say therefore R is a transitive relation. R is a transitive relation. So thus tinotai hol reflexive hol symmetric hol transitive hol. So thus R is an equivalence relation. So R is an equivalence relation. So the first part of the question is solved. Prothom part complete. Now come to the second part. Find the set of those elements of A which are related to A. That is, we have to find the class of A only. So you write like this. Clearly, we are asked to find the equivalence class of one equivalence class to variables. Therefore, equivalence class of one, this is equal to ki hobo eta one over kun jorito hobo one over one to thakiboi by property of equivalence class 1 over 130. Then you take those elements, ইয়াৰ পৰা সেইবোৰ এলিমেন্টস কৰি ল'ব লাগিব such that 1 minus that element is a multiple of 4 মানে এই রিলেশনটো স্যাটিসফাই কৰিব লাগিব। So 1 2 ললে নহব because 1 minus 2 is equal to 1 not multiple of 4, 1 3 নাহিব, 1 4 নাহিব, but you take 1 5, that difference is equal to minus 4 mod আছে গতিকে 4 is a multiple of 2. So 5 will come here, 5 12. Then 5, then not 6 7 8 9 will be there again, 9 twice above, then 10 11 12 13 but 13 is not in the set. So ultimately the class of 1 will be just 1 5 and 9. So that is the solution or answer for the second question. Your second question to our ever question is also find the number of partition in the set A set to partition we have used. So whenever we already question, whenever we are asked to find the partition of the set, then just you find the number of equivalence classes of the set under the given relation. Equivalence class jiman hobo number of partition of kiman hobo. That's to make it equal to find the partition, to find the number of partition, number of partition of the set A. Let us find the equivalence classes. Let us find the equivalence classes of the elements of A under the relation R. Under the relation. So therefore, class of 1, it already in relation, it is simply 1, 5, 9. Repeat normal class of 2. Class of 2, 2 itself, 2 to nije thakiboi, aro kon thakibo, jate divisible by 4 hoy, pare multiple of 4 hoy. So 2, then 6, 2, 6, then 7, 8, 9, 10, 10, 11, 12. Not 12 because 2 minus 12 is equal to 10 and 10 is not a multiple of 4. So class of 2 will be these elements. Then try to find class of 3. Even 3 will be able to try. 3. So 3 itself will be there. I don't know. 7. It will be 7. Then 11. Okay? No. It will have a class of 3. Then try to find class of 4. Class of 4. So 4 will be there, 4 is there. Then 8 will be there and 12 will be there. No. It was the class 5 will be 5 to the other side. So class 5 will be equal to class of 1. Class 6 will be equal to class of 2 because 6 belongs to class of 2. Class 7 will be equal to 3. Term repetition are more. So we see that there are 1, 2, 3, 4 number of partitions. Partition kya hol? Because they are mutually disjoint, pairwise disjoint as well the union of all these subsets is equal to the set A, and therefore these are the partitions. So we directly remember. So therefore there are 4 partitions of the sets. Directly remember. Therefore there are 4 partitions of the set A with respect to R. So equivalence relation R application happen from side partitions. So that completes the solution of the problem. So click on the problem. So now come to another question. লিখি লৈছো so now see this question let n be the set of all natural numbers তো আমি জানো হবে show that the relation r on the set n cross n মানে এবার সেট টু নিজেই অর্ডার পেয়ার n cross n set টু উপর রিলেশন ডিফাইন করা হয়েছে so on the relation r on the set n cross n defined by যেহেতু কি রিলেশন টু n cross n ডিফাইন করা হয়েছে therefore the elements of the set to similar elements they are itself ordered pair actually it was an n1 into ab then cd this is belongs to r এই সিস্টেম আছে বস্তু বাট এনে কোন কে লিখে দেখা গেল মানে দেয়া দেখি তো এই কারণে লিখে লিখেছে ab r cd relation is defined in which way in this way this if the ordered pair ab is r related to the ordered pair cd then the first and the last component sum is equal to second and third component sum. It is what relation. The question is this is an equivalence relation. You have to put that part. So to check whether this relation is symmetric, reflexive, and transitive, I will have to check for a So to check the relation is a reflexive relation, you need one element. Only one element you need. So this time the element should be taken as ordered pair. Because the relation is defining on the set of cross product n cross n. N cross n cross product or relation to define kora hoise. Therefore, you have to take the elements. Elements like in ordered pair. Actually, this relation is ordered pair of ordered pairs. Ordered pair of ordered pairs. Here is relation. So, here I am making a let say the ordered pair is AB is in n cross n. আমার টার্গেট টু কি আমার টার্গেট টু হবো যে ইজ ab আর রিলেটেড টু ab অর নট ab এর ab এর লগত রিলেটেড হয় না না হয় আমি একটু সলভ করি সো n + দেন একদম সিম্পল a + b is always is equal to জানতে হবে and that is implies you see the ordered pair ab is r related to the ordered pair ab হয় না কথা তো সবাই this first plus last that is a plus b then second plus third b plus c ultimately we have seen here that the ordered pair ab is r related to the ordered pair ab and this will satisfy for all ordered pairs in the relation r therefore this relation is a reflexive relation so you may write here for all ab is in n cross n therefore r is a reflexive relation. Reflexive relation. So this is the first part of the problem. Now come to symmetric part. Symmetric means this time you have to take two elements. Two elements mean this time you have to take two ordered pairs. Mean AB and CD. So let us take let ordered pair AB and CD. These are belongs to the set n cross n such that we take AB is r related to CD and our target is to check whether CD is r related to AB or not. But whenever we are taking AB is r related to CD, then by definition of the relation it should be A plus D will be is equal to B plus C. First plus fourth is equal to second plus third. And that is implies very simple b plus c can be taken in the left side, a plus d can be taken on the right side. Very simple. And that can also be written as c plus d is equal to d plus a. Very simple. And that can be written as cd are related to ab. You see, if you break down this one, then c plus d is the left side. D plus A is the right side. So, as we have taken AB is r related to CD, we have obtained here that CD is also r related to AB, and this shows that the relation is a symmetric relation. Therefore, R is a symmetric relation. Symmetric. R is a symmetry relation. So second part is completed. Now come to third one. This time you need three ordered pairs. Actually three elements, but elements are ordered pair here because the relation is defining on the cross product set. So therefore you take three elements this time. So take let the ordered pair AB, CD and CEF. These are belongs to the set of ordered pairs and cross such that the ordered pair AB is related to CD and ordered pair CD is related to the ordered pair EF. Now our target is to check whether AB is related to EF or not. So very simple. You first break down this one by using this definition. This implies first plus third means A plus D is equal to B plus C, and from here it is C plus F is equal to D plus E. So here তুমি এলিমিনেট কৰিব লাগিব CD বস্তু গতিকে C এর ভ্যালুটো নাই বা D এর ভ্যালুটো এই দুটো কোনবাটা ইয়াৰ পৰা আমি এটা পুট কৰি দিলে হৈ গ'ল so let me check put C is equal to D plus E minus F. Using this result here is equal to A plus D remaining here. B plus C is equal to D plus E minus F, and that is equal to this D will cancel out, minus F will come in the left side. So A plus F is equal to D plus E. Now is it not equal to AB REF? This one is this one. A plus F is this one. B plus E is this one. So ultimately AB is related to EF. So therefore this shows the relation is a transitive relation. So therefore R is transitive. And hence R is an equivalence relation. Okay, so you have another question of this type. Another question also just similar. Let n be the set of all rational numbers. Show that the relation R in n cross n defined by AB as CD is equal to, just change this one. A2 was to change to but AD is equal to BC. This is given as only the product AD is equal to BC and everything is same. To show that this is an equivalence relation. But the yellow telephone product process is same. So you want to solve this is homework for you. So let me take another question. So this is our question. Let R is a relation defined in the set of integers Z, and definition is given A or B is implied the product AB is greater than equal to 0. তাহলে এই বস্তুটো তোমাকে এনেকৈ লিখিলে হ'ব কিন্তু AB is in R implies product AB greater than 0. এইটো সিস্টেম মতো দিব পারে কথাটো একই হ'ব. So A or B implies the product is greater than equal to 0. So to show that this relation R is a reflexive relation and symmetric relation but not a transitive relation. So let me solve this problem. Solution. So first of all, let check reflexive. Let A belongs to the set of integers Z. Then you see A into A, it is always A square, and A square is a square of integer number, mean it is always a positive number, or it may be 0 because if A is 0, then A square may be equal to 0. So you can say this is always a positive non-negative integer number. So A square is greater than equal to 0. So since the product AA is greater than equal to 0, so therefore you can say the product pair AA, this is in R. This is R or এটো এলাকা লিখব পারি A is R related to A. এটো সিস্টেমত লিখি দেন R order তার লিখি দেন and this is for all A belongs to the set of integers Z. Therefore R is reflexive. একেবারে সেম R is reflexive. So first part. Next you take let reflex symmetrical কারণে দুটো লিখব A B. These are belongs to the set of integers Z such that this A is R related to B, and that is implies and implied by definition the product AB is greater or equal to 0. There as it. And product AB is greater or equal to 0 means the product BA will also be greater or equal to 0. This is also greater or equal to 0. And from this line you can conclude that B is R related to A. Gotike A or B is implies and implied by B or A. So this shows that therefore R is symmetric. R is symmetric. The second part is completed. Now to show that this is not transitive. So since you have to show it is not transitive, this time you take one counter example to support the statement. Ever can example need to show like this. So we observe third part we observe that say so minus 2 into 0, this is greater or equal to 0, নিশ্চয় গম পাইছা so here implies to কি লিখিব পাৰিম this will imply that minus to 0 is in R তার মানে মই ক'ব পাৰিম minus 2 is R related to 0 সেইটো ক'ব পাৰিম and এবার 0 into say 3 এ কৈছো this is greater equal to 0 greater equal to 0 greater than to 1 by 1 কিন্তু equal to মানে যেটো এই কারণে 2 হয়েছে তো 0 into 3 is greater equal to 0 so you can say that 0 3 is in R that means 0 is R related to 3 it only one 0 is R related to 3 now you see but even measure 0 to drop with that minus to 0 then 0 3 if you drop 0 then minus 2 into 3 into minus 2 into 3 is equal to what minus 6 is it greater or equal to 0 no it is not greater or equal to 0 so therefore minus 2 is not R related to therefore minus 2 3 is not in R that is minus 2 is not R related to 3 etc. And for example, therefore R is not transitive. R is not transitive. So this completes the solution of the problem. তো এটা কাম করব আমি আজকের ক্লাসটা এখানে শেষ করলে আর একটা ক্লাস হলে আমার চ্যাপ্টারটা শেষ হবে সো থ্যাংক ইউ ভেরি মাচ